Greg Claffey with M2 Renewables. We're here today to describe and talk to you about our MicroScreen here operating at the wastewater treatment plant in Bastrop, Louisiana. So what I'd like to talk to you about now is a little bit of the effect of the M2R MicroScreen, how it affects things downstream of the processes. What you're looking at here is an example of a wastewater treatment plant, and our effect on the wastewater treatment plant is actually pretty significant. Lots of people think of our MicroScreen as a headworks process. It's not. It's a direct replacement for primary treatment. So it's a direct alternative to what you're looking at here to my left, which is an example of a primary clarifier. Now these clarifiers are typically built off of and sized off of surface overflow rate that create a settling effect that could take hours, which determines the diameter and the depth of these processes, which you're looking at here. These processes are conventional technology. They've been used for 30, 40 years, fairly effective. However, what you're looking at is something that takes a significant amount of space and a significant amount of O&M maintenance and power requirements. And when you're looking at these tanks here, these tanks can be replaced by what you're looking at over there is our M2R MicroScreen, which is about a 4.5 foot by 4.5 foot by 5 foot box that can replace something that's entrenched in concrete in this size here. Very low maintenance, low space, very compact. And the reason for that being is because the M2R MicroScreen's concept is built off of physical separation. So the retention time inside that box is somewhere between 14 and 16 seconds versus something that would be hours in a large primary clarifier by what you see here. The most amazing effect that we've seen with the M2R MicroScreen is its effect on biological treatment. What we're able to do, which is a huge advantage versus primary clarifiers, is that MicroScreen is that even during high flow conditions, we're able to trap the solids inside of a box versus having those solids in that blanket be taken up over the primary clarifier into the biological process. So during high loading and high flow events, even though our belt porosity is only about 340 microns at our larger size, the downstream particle size coming off our MicroScreen is typically between 37 and 40 micron on that belt. And that's during high loading events and low loading events. What you're able to do then is can change the size of the food that the biological process is then able to consume. So based on that, the science behind it is that the amount of time and energy that a bug takes to consume BOD is directly related to the cube root of the size of its diameter. And so what we're able to do is take something that would be baby peanut size feeding the bugs and turn it into a coffee ground over the entire course of the day. Very common food source, which allows that BOD, that whole process, the aeration requirement, operates in a very, very small window over the entire operation of the day, which ends up saving money on cost because you operate where your blowers and your effective biological process is most efficient over the entire course of the day, other than operating at the very severe ends of the spectrum, which then operates outside the efficiency range, which then raises costs for the wastewater treatment process. So now I'll walk you through the operation of our M2 Renewables MicroScreen. What we're looking at here again is able to treat 750,000 gallons a day of primary treatment, a direct replacement and alternative to primary clarification. As the wastewater comes in, you can see the influent pipe over here to the front of the screen. Inside you'll see actually what we consider our inlet, which is a triangular type shape which gives us good distribution of primary wastewater down to the section of the belt. What you're looking at directly here, which is the empty portion, is the overflow. So as the wastewater comes up and over and you go into an overflow condition, that wastewater will then overflow this weir, and then your overflow then is taken downstream. The goal here is to entrench the wastewater inside the box in front of the weir, and what we're looking at is we're looking to create a filter mat on a rotating belt assembly that will create a certain head loss across the screen to collect solids. So as you look at the wastewater coming in, those solids will build up on a rotating belt and will continually to increase by removing more and more TSS as that water level increases. As you can see, entrenched in the wastewater, you'll see grease solids, solid material, FOGs. The way our process works can handle high levels of fats, oils, and greases as well as solids, and we'll go through that process in a little bit. Great, so I'd like to walk you through kind of how the wastewater flows through our MicroScreen. What you're looking at here is our influent pipe. The wastewater flows through this pipe into this distribution hatch. This distribution hatch distributes the water evenly across the bottom section of the belt. This section here, what you're looking at, is the actual overflow condition. So if the plant were to go into a high flow condition and more flow than what the screen can handle, it would come up over this weir, discharge out through the discharge of this overflow condition into the pipe, and you take that beyond the plant. As you can see, we're maintaining a pretty constant level of wastewater in this tank. Through the PLC program, we're actually measuring the water level inside this tank. As the solids, you can see the floatables collect in the bottom portion of the belt. The PLC will then tell this belt assembly to then turn and operate, and then speed up or slow down accordingly based on the solid loading condition, which increases the water level and or flow condition. So this water level is kept at a pretty constant rate. As the wastewater flows through, we'll walk through, you can see here that the solids collect on the belt surface. As the solids collect on the belt surface, the belt knows to turn on and operate, and this belt really just, the solids settle on the top portion of the belt, and the belt then moves the solids from bottom up to the top portion of that belt assembly. And when you get to the top portion of this belt assembly, the solids are actually just sitting on the belt, they come around the bottom, and then in between the belt assembly, there's a wash water line. This is our patent wash water knife, where there's flat fan nozzles, low flow, low pressure condition that just really use a little low force condition to remove the solids off the belt. Those then solids are sprayed down into this collection trough where there's a dewatering auger. The auger then transports the material into a dewatering section where we're able to dewater the solids to approximately 30 to 40% dry solid material. So this is all operation automatically. There's very low operator attention, and depending on the solids in low flow and high flow condition, the belt will adjust accordingly. So what we're looking at here is the top end of the M2R MicroScreen belt assembly. As you can see, the belt rotating typically between 10 and 20 RPMs depending on the amount of influent flow coming in. But you can easily see the corn and the large material, which you're not really able to notice with the eye, is all the hair and fibrous material that's removing. So as the solids collect on the belt, you create a mat. The belt removes those solids up and over. Underneath, you're actually watching our patented wash water knife, which we're actually washing the solids off the belt with about low volume, 60 psi, portable water, or we can use screened effluent or plant effluent water to filter those solids. And it basically cleans the solids off the belt into this auger trough, which will then auger the material off and then dewater it. But what you're looking at is a very common, clean, easy source of cleaning the belt. The most difficult thing to do is clean a belt. The most easy thing to do in wastewater is screen it. And we're combining simplistic technology to do that of both. So the wash water is your first line of cleaning effect, which is followed by a small scraper assembly. You don't want to have a scraper assembly first. What that would do would impregnate the belt, which would make things more difficult to remove, whereas we use a very low volume, low pressure wash water to clean the majority of the belt and have that small scraper assembly behind it to then keep any of the stuff that sticks to the belt, but you can see it's very little. So what we're looking at here is the M2R MicroScreen PLC program. From an operations standpoint, the system is fairly easy to operate. As you can see here, this is a cross-section view of the actual microscreen, and what we're doing is we're measuring the incoming flow as well as the water level inside the tank. So this microscreen, even though it's primary treatment, operates no different than a typical headworks screen. As the filter mat increases at the bottom of the screen here, the water level will increase over time. As you build up solids, you'll actually create a mat which will decrease your amount of open surface area on the belt. When you decrease the open surface area in the belt, that water level will rise. As that water level rises, the screen will then know that, hey, my screen needs to be clean. So once we hit a certain set point level on the microscreen, the PLC will determine what that level is and then tell that belt to operate and turn on. More importantly is the belts are operated off of VFD, which allows the plant to handle peak instantaneous flows as well as average flows and low flows, so that the belt can either speed up or slow down according to flow and the water level in the tank. Most plants and engineers will understand that even during high-level peak events and rain events, the concentration of solids in that wastewater is typically the same. So even though I'm increasing my flow, my concentration of solids is still the same. So there's no reason for the belt to clean quicker based off of just flow, because you still want to create your filter mat, and that is all based on water level in the tank.